Hi, everyone. Welcome to this AI monetization podcast with ProjectPro. I'm Binny, the co-founder of ProjectPro. On this podcast, we speak with industry leaders on what business outcomes they are seeing with AI. And Agritech has been a huge use case for AI recently. We have with us, probably the best person to give us an idea of what's happening with AI in AgTech. We have Patricio with us. Patricio has over 20 years of experience as data scientist in machine learning, as well as decision sciences. Patricio is currently the head of end-to-end decision science, focused on seed production innovation at Bayer, where he has been for almost 7 years. Patricio is also an adjunct faculty member and part of the industrial advisory board at the Washington University in St. Louis, where he also did some of his doctoral work. And then Patricio, before that, spent about 5 years at Monsanto as a data scientist, technical lead. Patricio, thank you so much for taking time to do this. Welcome to this podcast.
Thank you, Vinny. It's a pleasure for me to be here, and I'm really looking forward to entertaining and joyful conversation with you and with your audience.
Thank you. You've spent 20 years, over 20 years in the space, long before AI was cool and AI was probably called statistics back then. How have you seen decision making evolving, AI's role in decision making evolving over the last 2 decades?
Well, several changes, Vinny. One of the key one is the change on how we do compute. I think investments on the basic infrastructure to enable the calculations, so more complex calculation at a scale, has allowed us to then test and go back to neural network type of frameworks for us to do modeling. So that's one thing. I'm actually witnessed the time when neural networks back in the 90s start kind of slowing down, and then all of a sudden, during the first part of the decade, in 2000, 2002, the appearance in conferences started diminishing. So I saw that, and main reason it was the computational power that we have access publicly, I would say, at that time. But thanks to that change, and we today were able to have the luxury to embrace a high number of computation, plus the advancements on scalability or computational scalability, which is also driven from mathematical advancement, had allowed us to now today to dream and enjoy of algorithms such as large language models that today everyone is massively consuming. So that's the number one, I would say, key change in the industry that I witnessed. Second, algorithmically speaking, there is a huge variety now today in terms of learning, or what we call artificial learning, that talks about the creativity and our understanding on how humans learn. I mean, you can see aside from the classical learning algorithms like supervised and supervised, we have a huge I would say, push for range for learning type, with constructive learning, neuro AI learning, and so on. So there is a flourishment in the type of methodologies pointing towards how we learn and what can we learn from biology in order to establish new paradigm for learning from actual data. That's something that you can see in the literature. The way in how we generalize, so we understand the generalization performance of algorithms, that also changed in the last decade with new ways. For example, just to be very concrete, the introduction or the formalization of nested repeated cross-validation compared to classical cross-validation. That shows our need to find unbiased ways to understand how algorithms will generalize. So there is a lot of effort. The creation of new programs in the educational industry. You see that now we have many universities in recent years launching degrees that are specifically targeted to data science or AI domain, and refreshing the curriculum and the syllabus, targeting more to to the applied components and the industrial application of developments of algorithms, not just the mathematics or statistical learning focus, but also in their ability to apply this. So everyone has been evolving and adapting to the needs of the world when it comes to the use of AI. And finally, of course, the most important is, I would say, the democratization of accessing these tools on a day-to-day basis for our public use or personal use, but also how the industry has been embracing this to change decision making. I mean, a key there is the work that I have been exposed to while joining originally Monsanto and now later Bayer Crop Science, where we have a passion for innovation and technology, but for seeking opportunities to introduce efficiencies in the way of how we make decisions, the way of how we think about scalability, try to ensure that we're able to deploy quickly, try to ensure that we have best practices to introduce quality control. So it's a revolution. I would say in 20 years, I have witnessed going from a simple mathematical development, writing in a snippet or a code here and there with code run from my own computer to now running on a cloud infrastructure. So I think we shouldn't forget about what cloud infrastructure did to this industry in these 20 years with huge propositions, and they continue to do so. And today, they are technically sustaining and supporting the future of the use of AI in the industry and in the private world.
Makes sense. Makes sense. And specifically in the field of agriculture, precision agriculture, Patricia, and with the latest flavor of AI, which is generative AI, has that unlocked lots of new use cases, or has that helped you do kind of traditional use cases better? How has that impacted?
Yeah, so the area of precision agriculture is beautiful. Starting from what it means to sustainable agriculture. So the ability to understand the environment where we grow now and targeted to the genetics that we want to plant on it. So it's a beautiful exercise that is inspired by the need to create more with less, right? And also and has a lot of beautiful consequences for society. One of them fundamentally is that if I can generate the same amount of material or seeds in this case with less resources, therefore I am technically being more ecological consciousness, right? Conscious, and therefore faithful to our pledge to enable a sustainable agriculture. The fundamental part here consists of, can I use, first of all, new sensing technology to understand at high resolution or industrial target resolution the environments where I want to grow? Can I understand properly soil properties, the topography of the field that I'm choosing to plant? Can I understand also the management practices that historically have been technically deployed on that field or applied to that field during the season? Can I understand the genetics? But fundamentally, what AI has been helping us to I would say, grasp or better grasp compared to previous years is the ability to understand how our genetics interact with those environments. The challenges that we have faced in the past is not just about our ability to do artificial intelligence, machine learning, or statistics, or meaning leverage the data collected. Actually, one of the challenges is the ability to stack this information together, what we call data connectivity, right? Or creating the right set of information in order for us to create those insights. That's number one. So can we generate the information? Do we have the right sensing technology first to create the information needed to fit into those molds? The second component of that, do I have the right infrastructure to process at a scale the transformation of this data set into one common framework that can enable my analysis later on? Third, of course, do I have trials that allows me to basically, in a proper manner or in a scientific manner, using experiments, control experiments, to understand effects and get to the core of precision agriculture, which is causality. If I have this genetic with this variable seeding rate, am I able to understand what will be the performance in terms of yield and what will be the variance around it? So in order to properly craft that, I need to also invest on having trials that then will allow me to translate those into growers' fields to make proper recommendation. So precision agriculture is a lot of things, and AI is one of the components who definitely has helped us basically advance the way on how today we prescribe the work. What is beautiful about it, and I will say, what are the key learnings, is to understand that our planet, because Bayer, we like to think about us as one of the largest farmers of the planet, because we operate in all continents. But with that comes the beauty of understanding that anything we do to actually save resources have a direct impact into enabling sustainable agriculture, not just in the United States, but also everywhere where we are operating. And that's beautiful. You wake up in the morning thinking that, yes, as an electrical engineer, right, trained and signal processing, array signal processing, and AI, machine learning, now we have the opportunity to really help collaborate with our agricultural experts, our business lead, in order to move the needle towards ensuring that sustainable agriculture becomes a reality today, better than yesterday, thanks to the use of technology or data science technology, in addition to leveraging the agriculture expertise that the company has created and developed through years of working in creating seeds from the ground.
Yeah, makes sense, Patricia. It's amazing how you call it beautiful, and the whole idea of sustainability being core to what you do at Bayer. Yeah. And could you maybe help us understand some use cases that you have kind of seen on the ground and business outcomes that you're seeing with AI at Bayer itself or in your space?
Yeah, of course, of course. So in that case, precision agriculture, if we expand a little bit more, right? One of the decisions that you want to make in practice is, right, how many seeds per acre do I want to plant on this specific soil that I have in front of me, right? On this year, on a given year, right? That's a decision that is complex. Now, of course, the farmer knows his fields better than anyone based on the experience. Now, but there is a chance, though, of course, that changes around the collective knowledge that they have on how it operates might lead us to better outcomes, more efficient outcomes. And from a decision-making perspective, what AI and operational research brings to this conversation is the ability to control the risk. Despite the fact that we know or we have historical experience on how many seeds per acre to plant on this field, we are still subdued to the unknown and the unknown of the weather, right? We don't control weather, and therefore we are exposed to changes or to new dynamics that could get manifested in the area that we grow. So decision science comes as a tool to help you reduce the risk of the unknown. And that's where the knowledge of the local behavior of, in this case of a plant we saw, based on trials and based on the historical experience of the farmer, now give us the opportunity to bring other areas around the world that share similarities in terms of the environmental composition of that landscape that I want to deploy a product. That is technically today possible thanks to the investments on data and infrastructure, thanks to the investments on cloud compute, thanks to the investments on new artificial intelligence and machine learning paradigm, thanks to the investment on efficient experiments. Today, based on that collective knowledge that we have, we can make recommendations and understand better how much risk are we engaging on by making a single decision. So that's kind of the paradigm that decision science is offering today to a farmer. But then if you go to other areas, you can actually start asking yourself question, how much inventory should I hold today based on the dynamics of my demand this year, next year, and based on my production capacity, right? Those are decisions that you need to make every year, and I would say many times in a year, depending on the type of supply chain that you're working on. If it's chemistry versus row crop seeds versus vegetable seeds, there's always this decision of how to balance supply and demand in a proper manner so that we don't hinder ourselves by having too much inventories, right? Versus not having enough inventory to fulfill the needs of our customers on time, right? And so that's another decision-making process that takes place in what we call today supply chain. These are planning problems. So a planner has to make the hard decision of how much buffer to make in order to fulfill changes in the dynamic of the customers, or how much to promise to make based on his understanding of the production capacity that different plants or different fields can provide for the specific campaign.
Makes sense. And one of the interesting things I think I was reading a couple of weeks back was that weather prediction has become a lot more reliable in the last 24 months with a bunch of these AI models. Does that sound right to you? Is that something that you're seeing on your
It
side?
depends.
Okay.
I think it depends. So I think I would say there is a conditional statement to, there is a conditional, I would say, yeah, a statement to that phrase that you just made, because it depends on where you are in the planet. There are areas where the dynamics are much or less predictable than others. I mean, it depends. So in the Midwest, classically or traditionally, we like to say, based on our own internal studies, that you can go beyond 2 weeks, right? The degree of predictability. Now, let's think about that predictability, right, in terms of absolute sense or mean square errors around a particular outcome. It might have different criteria depending on who you're asking. Do you want to be precise within 2 degrees Celsius or 2 degrees Fahrenheit, or it's good for you to know that this year will be hotter than the previous year, right? And so it depends on what specific metrics you're looking from weather, right? Are you looking to understand when will be the last freeze day so that I can enact or activate my planting, right? Or when will be my new freeze day so that I can harvest before time and I don't damage my crop. So that depends on the actual parameter that you are interested in whether you might have different degrees of predictability.
Makes sense. One of the things you mentioned last week when we were speaking was this whole 2 paradigms of autonomous and augmented AI. And you spoke quite a bit about your belief in respecting the user. Could you maybe elaborate a little more on how you think about it?
Sure, Vinny. You know that is something that I personally learned while working in Monsanto first and now Bayer Crop Science. And we learned that to start distinguishing that paradigm, when we saw the behaviors of our colleagues when facing the adoption of a particular tool. And so I would say it's a personal story of awareness, personal story of awareness when it comes to embrace technology. And I would like to start telling you this story from a phrase that a very good leader of, and I would say a champion of transformation told me. Is that in order to disrupt others, we need to start by disrupting ourselves. That was a technically leader back in the time, Stan Dodson, who actually challenged the whole unit at that time. We were not called IT. But the beauty of that phrase is that it resonated in many of us to the point that if I am here and I'm talking to a field supervisor, a grower, and I'm saying to him, hey, I want you to use this model that will give you a recommendation on when to go and do planting, or how to do variable seeding rate in the field. Right? When you are confronting the person with that recommendation, obviously the first reaction will be, I mean, why should I trust you?
Yeah.
right? Why should I believe you when, first of all, you're not an agronomist? Second
Right.
of all, you don't know this field.
Right.
What entices you to technically ask me to follow this recommendation?
Right.
And so that technically goes in the faithful manner to this statement that was told to us by this leader in the company. Because if I am not capable myself today of embracing new technology to do my job, for
Yeah.
example, using assist AI to do my coding,
Hmm.
right? Or using any other tool to improve the speed of developing a code or maybe a mathematical development,
Yeah.
right? If I'm not willing to disrupt my job, how can I actually expect others to disrupt themselves to
Yeah.
follow it? So
Hmm.
that's the first principle. The principle of technically be willing to embrace change in
Yeah.
order to ask others to embrace the same thing.
Right.
So with that comes the fact that one of the key challenges that we face when asking or inviting others to join basically this journey of using AI and operational research to drive decision making using data is to confront ourselves what we call a basically trust in the technology. So in order to trust, we need to verify, and therefore the invitation to adopt this type of technology comes to engage, play, test, POC, and then deploy, right? Use a life cycle or a maturity cycle to deploy the technology, fundamentally centered around the pain points of the user to ensure that we have a proper customer journey mapping where we understand right from the beginning to an end what is the type of problems that we're trying to solve, centered around who is going to use it and being respectful that that person will need to take the flag
Yeah.
and move it forward once the solution is deployed.
Hmm.
And fundamentally, because today the liability of any decision still relies on a human,
Right.
right? He's responsible for ensuring that we have enough production outcomes at the end of the season.
Yeah.
The planner is responsible to ensure that the plan is as accurate as possible. The field supervisor is responsible to ensure whenever we send him to the field that he's using efficiently his or her time in order to go and technically scout the fields accordingly and report back.
Yeah.
And so the paradigm that I'm trying to describe here is this. In as to summarize, there are two main paths that we can embrace today. One is the looking to augment the cognitive abilities of the user so that that user or that basically that persona can act on a day-to-day basis and improve their ability or their throughput on a given task. The other task that we have, or the other paradigm that we have with AI, is the one where it's autonomous designs,
Yeah.
where we're looking to reduce the inter or across subject variability on a particular task given to the interaction of multiple humans by using basically an algorithm or introducing automation, right?
Yeah.
So those are two paradigms that you have in the industry. And I think we need to be very careful when we approach users to drive the adoption or to engage with the technology. We need to be very upfront. What is the end game so that we can have proper partnership in technically ensuring that we achieve the business objective that we want to have as a company? I mean,
Yeah.
I think at the end of the day, and I would put it simply like this, when we're part of a company, we can't forget that we're truly companions on a journey. We
Hmm.
all agree to embrace one vision. Let's
Hmm.
say in this case is hunger, health for all and hunger for none, right? We're all committed to ensure that we are able to fulfill that mission. But therefore, we're companions in the journey. Everyone has different responsibilities. And AI is an enabler. And therefore, we need to be sensitive that, at least for an internal operation perspective, these tools are helping my partner, my companion, to make his job better, faster, and more productive so that we can achieve our goal in a much faster than before. That's kind of now when it's for digital farming, our role is to ensure that our farmers are successful when it comes to confront the season and ensure that they can yield as much as possible so that they can profit from their labor.
Mhm.
right? Nevertheless, we're companions on a mission. And that's the human nature from a leadership perspective that we need to keep nurturing when it comes to raise the flag, here I come, I'm giving you AI to do what, right? To improve yourself, not to replace yourself, not to take you out of the job. And that's what I was referring to you in practice, right? That we need to have that consciousness about why are we doing this and what is the purpose,
Yeah.
right? What is the end game that we want to achieve as working together,
Yeah.
right? Towards to fulfilling our vision or mission as a company.
Yeah. And as we get helped by these AI assistant, Patricio, and then we get so much more productive, so much free time, a lot of our time frees up. What do you think we'll all end up doing with this extra free time that we have on our hands?
Vinny, I would like to say, I would like to adjust a little bit what you just said and say, I don't think it's free time.
Mhm.
I think I understand from the current universe, right, of task, if we are replacing tasks, logically, we would feel that we will have more free time.
Yeah.
Actually, in the contrary, I think this is a dynamic relationship.
Mhm.
When you're able to, if you're really committed to fulfill the vision, right,
Mhm.
any tool that you have should propel you
Mhm.
to look for more. In fact, today,
Yeah.
the current circumstances of the industry is that we want to do much more.
Right.
I mean, but I don't have all the resources.
Yeah.
I don't have all so the people, right? I don't have maybe the budget to engage on new technology or new sensing technology, right? So there is more to do than what we're able to do today.
Right.
So that's today the framework. And if you are in an industry that is excited and competitive, right, that should be the profile. So this technology, the framework of this technology, guys, we're going to increase our bandwidth so that we can do everything that we need in order to be successful.
Mhm.
So I believe, Binny, what has happened to me personally is that I'm able to do much more than before,
Yeah.
explore new ideas.
Yeah.
I mean, if we are curious, we're always going to be on the learning path. So I would say no free time. I think we're going to be able to do more.
More. Yeah. Yeah, no, that makes a lot of sense. I guess as humans, we always strive our imagination to just more ambitious things that we want to keep doing. So yeah, makes sense. Yeah. And Patricia, the other thing I was curious about is uh, uh, data is obviously the foundation to anything that comes on top of it, be it straightforward analytics, data science, or AI. In an area like agriculture, where data is kind of spread out, data comes from very offline physical components, IoT sensors, weather. Are
Yeah.
there best practices on how you bring all this together to kind of make credible analysis on top of that?
Yeah, you know what? It's just a beautiful topic because it has several frameworks. So first of all, when we talk about data, you can say, well, sure, do I have the right infrastructure? First, do I have the right sensing technology at hand in order to measure what I believe is needed in
Yeah,
order to drive this, right?
yeah.
So we start from the sensor. Do I have the right acquisition pattern?
Mhm.
So the second is, do I have the right storing system to ensure that at a scale I can record and then I can retrieve it, right? And at a reasonable price. And I'm talking about cloud in that case, right? Do we have the right infrastructure for us to maintain these records that are coming at different speed with different volumes, right?
Yeah.
That's the paradigm of big data that I'm technically telling you back here. But then it comes the game of, well, multimodality. Today, we're talking about multimodality because you can see recent investment talking about bringing together text, video, right, images, right, and any other information that you want. So the ability for us to combine this information, right, in a way that I can process them to do proper sense is key. Mm. Years ago, I would say where were we on this? It was our ability to stack different geospatial frameworks together, stacking, right? So give me a little bit more. Well, what if I tell you that I have a satellite image, I have a soil map, I have a topographical layer, right? How can I ensure that I can process it right properly is to give a recommendation into the field. In this case, we were talking about geospatial stacking and gridding, right? Having basically a proper image completely aligned, co-registered with the same latitude and longitude, so that we could technically create a vector that then we could use for inference or forecasting or to as an input into an operational research model that will create a prescription.
Yeah.
So that was a space combining a space, right? Different measurements but today the paradigm is becoming more difficult because the paradigm today is combining multiple structures that are not Euclidean in nature. And by that I mean structures that cannot be represented directly as vectors that then we can add, subtract, multiply in order to basically fit into the machinery that today gives life to the execution of any model, right? So the beauty is, how do you combine a graph, for example, with a video, with a time series, in order to technically be able to fit into a model?
Yeah.
That's the current paradigm. And there are many ways today on how different companies and research labs are technically embracing the challenge, right? For example, doing embeddings and then creating a common feature space where you can work on it.
Yeah.
That is where I will say is today one of the challenges based on what you're asking me. How can I fuse different information, right? Technically, no unstructured data, right? Combining unstructured data into a common space, which we like to call, right, Euclidean, because of the operations that technically allow us to do to fit into any AI or machine learning machinery.
Okay.
And I would like to add that as we are investing on it, right, you can see recent startups of Murati, right, from OpenAI, right? That's actually one of the objectives of that startup. Something that still we need to remember, right, as people are working on this problem, is to ensure the security of our data, who has access, but also the reliability of the information that we're collecting. I mean, if we don't keep attention to the quality of the data that we're collecting, nothing else will make sense after, right? And I think that's where I would say sometimes we tend to forget, right, where to put investments, and we tend to technically prioritize differently. I think we should not technically forget about investing on bringing the right sensing technology to accelerate the way of how we consume information, so that we can actually channel and propel decision science as a whole, right? That's key. That's key. And for that, I mean, for example, and for that, I mean, is having let's say, a sensor of moisture, right, in place, or having technically something that is scaled that allows us to go to every field, right, at the same time with low cost. So rather than probably using a person scouting the field at the same time, maybe we can leverage other strategies like bringing or leveraging remote sensing satellite images, so that we can actually on a daily basis monitor fields and be more purposeful about how to make more in situ collections. So those are examples of strategies that today could help us accelerate the art of using AI for decision science making, but taking care that you have the right data at time at an economical cost.
Makes sense. And once all this data is in place, Patricia, one of the things, again, you spoke about in our last conversation was this whole development of best practices for data science to control the variability of the data products, the analytics products that teams build. Could you maybe just help us understand why is that needed? What is the problem there? And how would you solve something like that? Are there solutions that solve that in the market today?
Yeah, yeah. So the best data science practices is something that I would say, first, I'm grateful that through the partnership with many leaders in Monsanto and Bayer, we crafted a life cycle that today is helping us to ensure that the models that are being created are of quality.
Okay.
It starts from the paradigm that, believe it or not, I work for and joyfully work for a product supply organization that is responsible for three supply chains: raw crop, vegetable seeds, and the crop protection. And now more embedded into the raw crop seed generation. But and why I'm saying this story, because as my colleagues from product supply are responsible for manufacturing kernels or seeds that are going to go into the hands of our growers, I'm responsible for designing the strategies of a manufacturing analytic solution. So we're also manufacturing.
Yeah.
And if you think about it, the manufacturing of analytic solutions is telling you that there are part of that process that requires for a data scientist to make decisions in
Yeah.
order to give life to a model.
Mm-hmm.
This is tell you a little bit more. Hyperparameters, feature selection, the actual step of the whole cycle of data transformation that picks the raw data and transform it into an actual solution. That cycle of activities is still manually driven, right? And it could sound like a very, very funny statement to say that we're creating artificial intelligence humanly crafted, right? And it's true. I mean, I think today, I think it will be very difficult to take a human out of the loop of crafting an actual analytic solution.
Yeah.
So, based on what I just said, therefore, the across subject variability when it comes to develop analytic workflow mandates first to have process for peer review, right? Decision science is a science and is subdued to the art, or I will say the process of peer review, the scientific peer review, right? We have a method, we have a hypothesis, and we deploy, and then we test.
Yeah.
I think that is the call today of humility. So the decision science life cycle is an act of humility to begin with. It's the act of humility, recognizing that we are prone to make mistakes or we are prone to make things on our own way. The question is this the best way
Yeah.
to ensure that the workflow scales?
Yeah.
Second, the workflow is adding business value. Third, the workflow is actually has the precision needed in order to become a proper IT solution.
Yeah.
So we need to put ourselves in a humble way and say, you know what? Let's talk about it. Let's review. Let's review the code. Let's review the science. Let's review the business value, right? So the life cycle, in summary, is technically represent the desire for us to acknowledge that it is as human, liable, accountable for making analytic workflows that work and can be sustained technically in order to become true solutions in the hands of any user.
Mm-hmm.
That's the philosophy. Now, so the life cycle in practice, again, is centered around personas. The life cycle is centered around the end user, right? Is the user basically seeing actually that this solution is going to, from a POC level all the way to validation to a deploy, is the user seeing across that change of creation that his pain points are going to be acknowledged? Second, is the business lead technically understanding that or that along the way of checking and balance and scaling up the solution that the return of investment is going to take place?
Mm-hmm.
And third, is it that a scientist realizing that the science that he developed or that person developed, he or she developed, is technically going to work, number one, according to the ideation, and second, is it going to scale? And so those are the kind of the pattern. I just named three personas, but the life cycle is technically centered around many personas. And so it's a way as a community to develop a solution in the fastest path possible to ensure that the solution is scale, is sustainable, is part of the target IT infrastructure, right? And so it's a ceremony, it's a set of ceremonies that allow us to ensure that we're coming together in alignment with the strategy that we set in order to deliver value at a given point in time in the organization. It has a lot of details, procedures, license to operate. Did anyone did this before? Exactly the same thing that you will face when you're publishing an article in literature. So that's where I would say you start facing or embracing the science component of what we call today decision science, right? It's the way on how we build things in order to support decision-making processes today based on data.
Yeah.
Now, something that we talk about best practices, and and this is for the audience, right? Behaviors is a key here. Embracing a life cycle is actually an act of disrupting the way on how we do work. Remember, I started the conversation. In order to disrupt others, we need to be willing to disrupt ourselves, right? And the act of self-disruption comes by embracing a way of working, which is actually this: the ceremonies involved that are nurturing the life cycle to ensure that my products are of quality.
Yeah.
That maturity is recorded from the data scientist that belongs to that organization.
Yeah.
And I would say a little bit more. If that data scientist has problems with people reviewing their code, then we need to work. We need to coach, right? In order to ensure that we give the right environment, the right culture to embrace critique and improvement. So we can't walk away from people. We talk about AI, we talk about machine learning, we talk about solution, but at the core, we are at the center of this technology.
Yeah.
The technology is surrounding us to make sure that we do a better job.
Right.
And so all of these frameworks, right, that we have in place gravitate around us. And therefore, we also have to have technically the right behaviors in place. So change of management for decision science organization is key. How do we nurture the right behaviors to embrace processes that help us be better at the work that we do? But then at the same time, change of management is needed in order for our final users to embrace these tools and be faithful to the investment entrusted in that particular function to ensure that they can do a better job. And that's the part that you asked me in your question, and I'm going to get there, which is called the last mile of analytics.
Right.
So I have best practices in order to ensure that my workflows are of quality, right? And that I'm faithful to the oath of science, peer review process, correct and check, right? But then at the end of the day, the job is not finished if the models or the recommendations are not being used. And that today in the field of analytics, we call it last mile of analytics, right? The job is not done until the model is being used, and then feedback comes back, and the tool is in the hand of our users. That is technically also a very beautiful component, and that paradigm has forced us to technically embrace different ways of design and changing our process. So a faster feedback reception to understand whether the user feels that basically his pain points are being taken care of. Second, giving him the security that these tools technically are meant for that purpose, or they don't have a hidden agenda, which could be maybe replacing that user from the particular task, job security. And third, ensuring that the user understands what the algorithm is portraying as an outcome to that user, meaning that is the user in full understanding of the graph that that person has on the screen, right? Is that person capable of understanding what that particular recommendation and the downstream implication of not following that decision? So two concepts that comes with last mile of analytics, also with technology to drive the change of management and the change of behaviors, are, for example, a contextual intelligence. That's where GenAI can help us today in the translation of complex ideas that a model is portraying into a natural language processing that the user can consume and process internally and say, oh, I agree or I disagree. Second, leveraging techniques that you can see in social media, like gamification, right? So that our interfaces mingle and interrelate with the user in a way that he feels rewarded by engaging with the tool. And actually, his feedback is taken into account to help improve the tool. Those are basic concepts that today you could actually learn, or you could face, or you could technically tap into as you are looking to understand what last mile of analytics can offer to ensure that the return of investment is granted at the end of the day.
Got it. And one of the other things I was curious about was that as you talk about best practices, in the world of front-end development and back-end development and full stack development, right? AI coding tools like Cursor and things like that are significantly increasing productivity in how fast developers can write code. But when it comes to data science, do you see a similar impact with help from AI to do things like exploratory data analysis or feature engineering or model selection? Are there a lot of help available for data scientists to do that?
Yeah. That was something that you asked about platforms, right? So today, there are many approaches to do that, and we have our own. So when it comes to technically enable that, it's key to have the right infrastructure to support that, from model monitoring, right, model deployment, and then model development, right? And from the university perspective, analytic workflow design or optimal analytic workflow design continues to be a very important topic, because as I mentioned to you today, you most often are encountering code where they're using the default hyperparameters of a given model, right? And sometimes because they can't actually tune them, because they don't have the computational power to do so.
Yeah.
So to answer your question, yes, there are tools today like something that we call auto-ML type of techniques. It's automatic machine learning that very quickly will basically help you identify through optimization techniques what is the right number of hyperparameters and features that you want to select. Cloud providers like Amazon within SageMaker, right, and other packages that they have offer you services like that for you to quickly understand how to design them.
Okay.
But nevertheless, if I have to say this in a nutshell, in the 7 years, we have seen specific frameworks that are helping us to do that from an optimization perspective. So we're moving away from the simple cross-validation technique into more sophisticated frameworks such as repeated nested cross-validation. And you can see that in the academic literature being proposed because it provides us an unbiased estimation of the generalized predicted performance of the algorithm. But it doesn't come for free.
Mm-hmm.
It's a more sophisticated way to technically stratify your data in order to ensure that you have the right number of faults technically properly balanced in order to answer how well this algorithm will generalize. And second, how can I properly compare the performance of an algorithm with other algorithms while at the same time I'm trying to find the best feature set and the right hyperparameters for the given morphism of function that I'm using.
Yeah.
And so academically speaking, you have more work on that matters. And in fact, recent work on the use of genetic algorithms, bringing this computational evolutionary framework to help optimize the art of putting a workflow together, right, with minimum time and proper resources.
Yeah.
So those are from academic perspective, and from software perspective, you have a bunch of software that falls under the auto-ML framework that are trying to do that in a cost-efficient manner. There is not a single solution for that, because all of the approaches that I'm citing to you will result in suboptimals. However, some of them will be better than others when it comes to find the right infrastructure.
Yeah.
However, a common thing, no matter how good your optimization is and how much computational power, you are still subdued to two things: the number of data available, the size, and the number of dimensions that you want to operate on, right? And so those two things will make your problem more challenging at the end of the day, and that will dictate how much funding you need to have in order to enable the right computational costs and in order to look and to implement more sophisticated optimization techniques in place. There are groups who have technically done a lot of work in evolutionary computational artificial intelligence to do proper design. There are a couple of groups, one from MIT and from private sectors, right, that are very famous today in that regard because of what they have done for deep learning, right? The art of technically changing the infrastructure rather than just using transfer learning and borrowing from the architecture of someone else. You can actually now go in detail using the same techniques that I mentioned to you, like a genetic algorithm with specific cost functions, to craft a different architecture for the purpose at hand. That technically is also another it's a paradigm that has been used for years, I would say more than a decade, and it's paying off. I mean, it's paying off in many ways, getting more efficient deep learning architectures to answer questions.
Interesting. And just finally, Patricia, you've done a good amount of work on predictive analysis for early medical diagnosis. So could you maybe help us understand kind of use cases of analytics to drive healthcare and medical outcomes that you're kind of seeing out there?
Oh, yeah. No. That's another beautiful. Life science is so rich, so agriculture, healthcare, medicine, right? And thank you for bringing that to the table. The field of healthcare has grown tremendously. When I had the opportunity to directly collaborate and do research from the university and the School of Medicine, the type of problems that we were working were centered around new data types that were coming on the table to actually help with diagnosis. And one of them is the human microbiome data or metagenomic data, meaning the ability to understand how many bacteria, so which kind of bacteria and how much of it was present on a given sample by doing genetic analysis of DNA present in the sample. And so therefore, starting from that time, where do I have the right mathematics to actually process this data? Going back to what I just mentioned, the ability to bring unstructured data into a Euclidean space so that I can run my algorithms that today run under that mathematical assumption. In this case, was the same thing. And so, but the problems that are being solved today were, can I actually understand the onset of a disease based on the genetic profile? Right? A beautiful example that changed the paradigm today, and today we have out of the ability first to design trials, to design the process to collect observations. Let's start from there, right? When I'm introducing a new technology, a new paradigm that was created thanks to the use of AI, machine learning, and statistics, is to create the right protocol to collect the right information when you don't have it. So starting from collecting observation all the way down to creating insights that today have become FDA-approved techniques, like, for example, pills that are allowing us today to seek for pills that have microbial content from a donor in order to help attack a Clostridia difficile, which is basically a type of bacteria that, if goes out of balance in your stomach, will bring you into an illness, right, that will provoke dehydration because of continuous release of your feces, right? And so, therefore, we have gone all the way from how to collect samples with this new technology, how to develop algorithms that are now helping us understand what is the impact of bacterial diversity in human health, in order to then how to design, right, a medical intervention that will help create health in our patient, especially in cases where the use of antibiotic is not helpful. But also, we have seen that the use of proper data collection system with right methodology has helped us understand how the human body works. And so there is joy in bringing health to an individual, but there is also joy in having the ability to go and wonder, oh, this is how it works, right? The fact of the insight is also something that goes to the heart of we being human beings, that we're always learning, right? Always discovery. And that's the second part that I love from the work that you have been seeing in medicine, is to the paradigms in data information technology has allowed us to technically continue to fall in love with the world that surrounds us, especially with the human body. And I would say that's beautiful. That's beautiful to understand or start accepting that bacteria were good for us and not just technically alien to us in a way that we're basically creating harm, was also a great insight. And you see how different products have been created in the industry, changing the way of how we eat, right? So So the insights on food are a good result. Another area, for example, diagnosis, right? Facilitating the onset of a particular disease or of a particular practice, the onset of labor. I did have the opportunity to contribute in human reproductive systems, understanding and trying to understand what were the mechanisms that will lead to, in this case, to a patient into labor? And do we have signatures in the way on how contractions take place or in the way on how bacterial diversity is manifested in order to predict whether or not this patient will have labor in the next hours? For example, in a collaboration with other groups in the South, where they're looking to basically understand, can we identify signatures in a kidney, right, based on a histopathological image that tell us that this kidney will fail or not? Can we reduce the misclassification errors of rejected kidney when it in fact could be used for a particular donor? So today, thanks to the use of, in this case, of medical imaging assisted with artificial intelligence, we have opened the door for us to learn more about how our body works. Second, use those insights to design more personalized, technically medical interventions that are bringing health. So there is a lot to go over there, Binny, and I would say you can see that I'm growing in joy because learning at the end of the day is, we can't forget that the following: if artificial learning or artificial intelligence is making you feel threatened, I will say, let's turn it around. Artificial learning or artificial intelligence is a tool for us to continue our path on this life, to continue to learn about the world that is around us, right? And giving us the opportunity to make better contributions in the short time span that we have to live in this world.
Oh, it's a wonderful note, thought to end this podcast on, Patricia. I mean, it was amazing having this conversation. Just seeing the full of joy and passion you have to what you do.
Thank you.
What AI can enable. Thank you so much for this.
Thank you, Vinny. And you know that I couldn't finish this by acknowledging the different mentors and coaches, right, that I have had. Usually we come to maturity in terms of thinking about technology, but it's the result of interacting with others. So we are, at the end of the day, a result of interactions with people, right? We are the result of a culture, right? And I would say that here from my PhD advisor, right, Professor Nehra, and my postdoctoral advisor, Professor Vichana, then all of the leaders that I encountered along this career brought me here to the realization that learning is awesome. Learning is awesome, and there are ways to systematically understand what is happening around us, right? From the proper formalization of trials in agriculture, with the meticulous realization and tracking that my agricultural experts at Monsanto and then at Bayer put on, the effort that they put on to ensure that we get the right data, from the business lead who are teaching us about how to make proper investment and ensure that there is a return so that we keep being profitable, to those who understand human behaviors, right? I think everything comes around, and I say I'm grateful to be able to share that story, which is basically the story and the narrative of value that many have brought to the table while working in problems in agriculture and in medicine.
That's a wonderful thought, ending on the note of being grateful. Thank you so much for that, Patricia.